going to talk about limits. Uh, when you are finding limits, there's some basic tricks, or you might call them techniques for finding limits. One is direct substitution. Direct substitution works if you don't violate any of the arithmetic rules. And the only rules that really you have to be worried about is whether or not you're going to be dividing by zero. The other issue might come up if you have an if then going on in the definition of a function. But basically, you're coping with dividing by zero when you're dealing with limits where direct substitution fails. When you are dividing by zero, you should be able to manipulate the expression so that no denominator approaches zero. And you can achieve this either directly through cancellation, through factoring, through differentiation of the numerator and the denominator using what's called L'Hopital's rule, application of a rule of inference from, for example, a geometric interpretation for sine x over x, for example, or the use of some other or some trigonometric identity. And so that's a very high level summary, and I hate that slide. Sorry. Don't like this slide either. There's some problems and related concepts that problems which relate to concepts. For example, if you take the limit as x approaches 1 of 5x to the fifth plus 3x minus 2 equal to 6, then all you have to do is substitute 1 into the equation and find that the left side equals the right side. There's no division by zero. This is fine. That's all you have to do. If you take the limit as another kind of problem associated with limits has this rather complicated phraseology, which asks asks that if the limit as x approaches 2 of 5x minus 1 equals 9, find d so that the absolute value of 5x minus 1 minus 9 is less than 0.1 when the absolute value of x minus 2 is less than d. What the heck does this mean? What fundamentally they're asking here is how much does this 5x wiggle? Okay, and that's going to be 5 times 0.1 in the example. So however much when we change x a little bit, how much does this absolute value overall change? How much does this overall function change? And that actually begins to connect us to the concept of differentiation, which is kind of the reason for the existence of the problem. But the problem is really a challenge in reading comprehension and memorization and relation of the definition of a limit to the problem. And so there's not much you can do about that other than to memorize the definition of a limit. If we have the limit as x approaches 3 of f of x, where f of x is 17 when x doesn't equal, I think that was supposed to be x doesn't equal 3, and f of x equals 5x to the fifth when x does equal 3, then what happens is that these two functions are not the same. 17 is not equal to 5x to the fifth when x is equal to 3. And so there's a lack of continuity, and so the limit never reaches what it approaches. So, but I mean, actually, the limit may actually exist, but so actually, we might want to come back to that one. And finally, x to the fifth divided by x squared plus 4. In the situation, you might normally think, well, we have to cope with canceling out the denominator by doing some kind of fancy factoring. But this is a little bit of a ruse here, because x is approaching -4 makes you think that when you see the 4 here and see the -4 here, you think that they cancel. But x squared is positive. This is 16 plus 4. The denominator is 20. There's no division by zero. It's a red herring kind of problem. So that's a quick introduction. And honestly, I just don't like this introduction to limits, but it does sort of enumerate some of the key concepts in finding limits. So it's a start for us all.